Now we're going to practice doing some normal probability problems. If this seems familiar, it's because you have done this before, but you may have forgotten a few things. So we will go through some problems to refresh your memory. The weights of 3-year-old females closely follow a normal distribution with a mean of mu equals 30.7 pounds and a standard deviation of sigma equals 3.6 pounds. Randomly choose one 3-year-old female and call her weight X. So this is considered a random variable because we are going to see a distribution of weights that would occur if we randomly chose a lot of 3-year-old females and weighed them and recorded their weights. Find the probability that the randomly selected 3-year-old female weighs at least 30 pounds. So we're trying to find the probability that X is greater than or equal to 30. Now remember we talked about if we just said more than 30 pounds and we said probability that X is greater than 30, that would have been exactly the same probability. Okay? That's what we're trying to find. So we are going to draw a picture here showing this. So remember, when we draw a normal model, we identify it by its mean and standard deviation using a big capital letter N with a parenthesis like this. Okay, so that shows our mean and standard deviation of our model. Then we locate approximately where 30 would be for X, so a little bit to the left of the mean. And then we shade the area that we are trying to find. We want X greater than 30, so we're going to shade this area here. And that's what we're trying to find, is the area under the curve. Now I want to recall the Z value, okay, or the Z-score. So the Z-score is the number of standard deviations from the mean. So what we do is we take our X value and we subtract the mean to see how far away it is from the mean. Then we divide by the standard deviation to see how many standard deviations that distance is. Now it turns out that number is negative 0.1944, telling us that we are about 0.2 or about 0.2 of a standard deviation below the mean, which looks really reasonable. Now I want to show you using a diagram what this exactly means. So this means that if I had a normal model called a standard normal model, where the mean was 0 and the standard deviation was 1, that the same value I identified on my first model with the shaded region here, this would be the Z-score, negative 0.1944. So negative 0.1994 is the same amount below the mean of the standard normal model as 30 is below the mean of the model of the weights of the 3-year-old females. Okay, now to find the area under the curve, we're going to use Normalcdf. So we could either use Normalcdf with 30 for our left, positive infinity for our right bound, 30.7 and 3.6, or we could use Normalcdf with negative 0.1944, comma infinity, comma 0, comma 1. So either one of those is going to give us the same value. When we do this on our calculator, this is what we find. Here's the value for 30 to infinity, 30.7, 3.6, and we see it's about 0.577, or about 57.7% of the time. We would randomly choose a young 3-year-old female that has a weight greater than 30 pounds. Now how do we get to this? Just to remind you, you go to Menu, Statistics, and this is a probability distribution. So you go to Distributions and then find Normalcdf. So let's do the other version. If I put in this Z-score and said negative 0.1944, and then the upper bound would be infinity, using the pi button here, you get the infinity, and then our mu and sigma are 0 and 1 because this is a standard normal model. See, we get the same thing. Now I use a rounded version here, so that's why it's slightly off on the decimal places, but it is the same number. So the answer to this then is 0.577. And that makes good sense because we are slightly below the mean, so it makes sense that we have slightly more than 50% of the area shaded in here. Now, probably I should write some sort of a sentence saying that the probability of randomly selecting a 3-year-old female who weighs at least 30 pounds is about 0.577, but I don't have room. Okay, find the probability that a randomly selected 3-year-old female weighs between 25 and 35 pounds. So I'm going to go through this one a little bit more quickly. So we have here, we always draw the normal model, always label it with the correct mean and standard deviation. Just draw that slightly better there. So we have 30.7, 3.6. Shade in the area that I'm trying to find. So I'm trying to find between 25 and 35. I know 30.7 is in the middle, so that looks pretty reasonable for my shading. And that's good to know because you want to, if your shading's kind of reasonable, you know if your answer seems reasonable. I'm not going to find the z-score this time. I'm just going to go straight to Normalcdf. My left bound is 25, right bound is 35. My mean is 30.7, standard deviation 3.6. If I go through that process on my calculator, I would end up with 0.827. I would suggest just making sure, going through on your calculator, making sure that you can get the correct answer here. This counts as showing work because I know it's a normal model. I have it identified as a normal model with a capital N. I have the mu and sigma identified. I have the shaded area identified. So all I need to have is this probability. Now, it's probably good practice to write your answer in a sentence form. So I'm going to say the probability that a randomly selected 3-year-old girl weighs between, it's probably really slow if you're watching this on video, weighs between 25 and 35 pounds is, and this is important, about 0.827. Okay, make sure when you're using a model you need to say about. Okay, the third example asks us to go backwards. It says, what's the probability that a value, that the random variable being less than some value k is 80%? So when I draw this, I'm just going to shade in 80%, or my reasonable approximation of 80%. So I'm going to say, yeah, maybe this is 80%. All right, so I'm looking for this area shaded in, area equals 0.8 or 80%, and I have still have my same mean and standard deviation for a normal model, and I'm looking for some value of x that would give me that particular amount of shaded area. So let me remind you that you find x using inverse normal. So inverse normal of 0.8, and then my mu and sigma, 30.7 and 3.6, would give me the answer. On the calculator, let's just see what that looks like. So we go to Menu, Statistics, Distribution. Inverse normal is just below Normalcdf. So I put in the area that I'm interested in. It always has to be the area to the left of your boundary line. My mu is 30.7, and sigma is 3.6, and I find that the weight that I'm looking for is 33.7 pounds. And that looks very reasonable, okay, because I know my mean's 30.7, so having this value be 33.7 makes very good sense. I want to show you something else, though, that if I want to find the z-score, and sometimes you need to, you put in 0.8, but then you leave this as 0 and 1. So when we do this on the calculator, so let's just go through and do that again using 0 and 1. I can copy and paste this and just change it, or I could go through, remember, menu 6, I forget what the numbers are off the top of my head, but menu, statistics, distributions, and then inverse norm. So 0, 1. Okay, this is the z-score. So this is how many standard deviations away from the mean cuts off a boundary of 0.8 on the standard normal model. So I'm just going to put 0.8416. So that would mean that if I was doing a standard normal model, I'll just draw that down here. If this were 0 and 1, this would be z equals 0.8416. And this would be 80%. So how are these two related? If I were to take the mean, 30.7, and add the standard deviation, or add 0.8416 standard deviations, I would get 33.7. So that's how the two of these are related. Now, it'd probably be good to write a little sentence. So how would you explain this number? Since we're talking about randomly selected 3-year-olds, we would say about, let's see, about 80% of 3-year-old girls weigh less than 33.7 pounds. Okay, so there we go. There's your normal model review.